Hello, everybody. My name is Gang Tang. I'm CTO and co-founder of Timeplus. Today, I'm going to introduce how Timeplus Python UDF can empower your data scientists and data engineer to build real-time machine learning applications based on our streaming SQL. Let's start. First, you may not know Timeplus, but Timeplus is a unified streaming SQL platform built for performance and efficiency with all-in-one binary. So basically, Timeplus try to simplify stateful and stateless streaming processing. And the interface is SQL, so it supports different input like TCP, HTTP, ODBC, Kafka, and a lot of others. And also, under the hood, it has a streaming engine, and it's a columnized storage. It has columnized storage, and it provides some powerful features, especially like materials view, which is like a continuously incremental processing of data and pushing data to some downstreams. Like you can push data to single database like a ClickHouse, or you can push data to like a stream platform like Kafka. So today's topic, I'm going to introduce about SQL and Python and how they work together. Right? SQL and Python are two of the most widely used tools in the data domain. Right? But both of them has a lot of users, but they serve different purposes and they're a little bit different. And here I have pros and cons comparison about SQL and Python. First, let's talk about the SQL. So with the SQL, it's optimized for data retrieval. So it's fast and efficient. If you have a structured data in your database, right? You use SQL can efficiently get all this data and query all this data. And it's this declarative. That means you just tell the SQL database what you want to achieve, right? Instead of write some code, it's actually specify what are the data you try to get, and then you get it. That's declarative. And SQL is standard, right? So it's very simple to use, and the SQL standard, that means you probably, if you learn one of the SQL, you probably can use it in some other databases. And then scale well, right? The database can handle large data set efficiently with some technology like index and query organizations. While there's some limitations about SQL. First, it's not very flexible, especially when you write something like a loop or conditions, or you want to control the logic of the code, right? It's not because it's declarative. It's not writing some code, right? So it's not easy to write those flexible or complex logic. And most of the SQL, it doesn't support like a machine learning or AI operations. So, like in the today's world, software world, AI and ML take a lot of important role in your application, right? So SQL has limitation to you to support these features. Also, in some other cases, traditional database they don't have a good support for the unstructured data like JSON. There's MongoDB has JSON support. Well, as of today, most of the modern database has added those unstructured data support. Uh, it yes, similar like in Timeplus, actually, there's quite a lot of functions to help you to parse JSON or extract data from JSON, or even have JSON types as a default data type. So that means the modern database has improved a lot for the how it can handle the unstructured data. And then let's talk about the Python. So Python is very flexible because you just write code, and there's a lot of tools, community tools like pandas, NumPy, that can help complex data transformations, and you can write your own loop or conditional logic. Uh, Especially next, Python is the language for machine learning and AI. Right, most of the machine learning functions are built in Python, and also today there's a lot of like AI related libraries like large language model support or agentic framework. So there are a lot of these stuff provided by Python community. The last one is the ecosystem, like mentioned. There's a pandas, NumPy, scikit-learn, TensorFlow, a lot of them. So if you're a data engineer, you has to use Python quite a lot because it's really very rich ecosystem. Right? But there's limitations for Python as well. So for large scale data, large scale query, Python is not optimized. For example, pandas. There are a lot of replacement or new libraries try to improve the performance of pandas, but provide the same. The pandas are really easy to use. People love it, but the performance wise, there are a lot of if you handle large data set, it's not designed for large data set. And usually writing Python means you need to learn a programming language, a new language. Uh, Compared to SQL, it's a little bit hard to learn, but still Python is not a complex language. So but still for some newcomers, new learners, it takes time to learn a new language, even it's Python, right? Next, like mentioned, right, for distributed processing, large data scale data, if you really look into performance optimizations, right, there's some tools like DAS, PySpark, some tuning that, if you really want to handle a large data set, sometimes you use them together, like SQL and Python. That's actually something I'm going to talk about today. So in the Timeplus, actually, there's a user-defined function. So previously, Timeplus already supported JavaScript and also remote UDF. And recently, actually, we have built this Python UDF. That means you can natively call Python inside Timeplus. There's no as a single binary that actually Timeplus is Python, right? That means you can directly run those Python process as a user-defined function within the same process. That means you don't have to transport data from one process to another. It's all the data pipeline, all the data is handled within the same process. That means you can leverage Timeplus to call this machine learning or AI functions or complex event processing or even any third-party library provided by the community within the Timeplus scope. This will greatly simplify your data infrastructure. So today I'm going to share something about how this Python UDF works in Timeplus, and I will also give you some examples of different Python UDFs, in different using different libraries. Okay. Next, let's talk about two different type of SQL functions in Timeplus. Also, it's a common concept in other database as well. So the aggregation function and scalar function. So aggregation functions operate on multiple rows. Here I have example here. It's a many to one mapping. That means if you want to run a summary sum operation on these input numbers grouped by colors, right? For the purple one, 1, 2, 3, we sum as 6. The 3 input to 1, and the green one 4, 5 to 9. That means we can take a look at this aggregation function that is many to one operation. So for several input to one output. Similar, the other concept is scalar function that actually operate on individual rows. So for example, in this case, I want to do a math operation add 1. So for each input, it get 1 more. So 1 to 2, 4 to 5. So it has nothing to do with the colors, but we just do a 1 input and 1 output. That's a scalar function. So here is an example of how Timeplus you can create a scalar function we call the add5. So here, the first line is the SQL definition of the function names, input values, input types, and the return values, return types, and what type of language to implement this user defined functions. It's Python. So there's $2 here. It's just a quote string. So the body of the function definition is a string. Using $2 because in your code, right? You probably use some other code like single quote or double quote. So using $2 can avoid this kind of conflict with your code. So one thing to mention is that here we have same functions, Python functions and UDF functions, add 5. But the input value here is actually not a number. Instead it's a list of number because in Timeplus, it internally store data in column format. That means, and also Timeplus process data in batch. That means if you have a multiple input arguments, it actually where Timeplus are processing this data batch by batch. So they actually group each input columns, input batch as columns, and send these columns or list to the UDF. So that's why here you got value is actually a list of the input values, right? So in the function body, we have to iterate all the input values and give each values F5, right? So that's how it works. Now I can show how it works in Timeplus. Let's log into Timeplus and take a look. So let me copy these functions and let's start the Timeplus. So I'm logging to Timeplus. So I can just run this in the Timeplus console. Say, let me move this under. So run this SQL. Yeah, the SQL has been created. That means we have this I5 functions now. So if I run select I5 to 1, you can see we get 6. And we actually can run it in a streaming query. That means if you have a number stream, right? If you run this function on your stream, it will continuously add 5 to your input stream. So we can show that later, right? Let's go back to the aggregation one. So how we define an aggregation functions. So aggregation function means you have state, right? When you aggregate something, when you get data, you actually keep the state and do the aggregations. So in this case, we have example called get max. So you have an input value stream. I want to calculate which number is the biggest number, right? It's kind of simple, right? We keep this, in the Python UDF, we actually, instead of the function, we put the function name as a class, right? And we keep the state, the max number, self dot max, to keep that state, right? And when we process the input values, you remember we put values in an array to the UDF functions, and we iterate all the values. If the current value of the data scanned is bigger than the max, right? We keep the max as current numbers, right? That's simple, right? It's just how we can find the max number in a list, a sequence of numbers, right? When the finalized function defines when we emit the result, right? Note we emit an array of the max, right? Because it may sometimes we process it in the column in the array format, right? Well, sometimes it emit for example group by, right? You emit multiple data at the same time. And the serialized and deserialized means because Timeplus is a distributed framework, right? Sometimes Timeplus will restart and you will recover from previous computation state, right? and sometimes you want to your computation process the process has been rescheduled to the other node. So in those scenarios, we will use serialize and deserialize to keep the state and restore the state. In this case, we just have a data that keep the max data, and then using Python Pico to dump the data. And for the deserialize, it's just load the data back. Right? And for the merge, because Timeplus is distributed processing platform, if you specify multiple shard or multiple thread to processing the aggregation, right? Actually, there are multiple thread doing this get backs, calculate max at the same time. And when we merge, we need to decide which is a real max from all the thread. Right? That's why we have merge here. So yeah, I can do let's do a quick test of this aggregation function as well. So in Timeplus, let me create these functions called getMax. Okay, and I need for the getMax, I need a number. So fortunately, I already get some data. For example, this Iris data set. Later on, we will use this Iris dataset to test the machine learning functions. But here, let's use this to test this aggregation function. So if we select everything from the Iris or the Iris table, yeah. Let's select the table function is actually turn the stream to a snapshot, right? It's same as a traditional database. I have this Iris dataset. Probably I want to get which is the max sample length. So yeah. So okay, let's get back to the introduction. Okay, so that now we have this aggregation functions and the scalar function concept. Let's continue our introduction. So next, I'm going to share you some machine learning libraries, how we integrate, how Timeplus Python UDF integrates with machine learning functions and machine learning libraries, and do the back training and streaming inference. So there are a lot of popular machine learning tools like scikit-learn. It's the most popular one. People use it quite a lot. PyGarrett, this is a low-code machine learning library, so you don't have to. It can help you do the model selection and hyperparameter tuning. So it's quite very a good tools. If you are not a data scientist, you don't know the complex concept behind machine learning, you probably can use PyGarrett to simplify your model selection process. And also like the XGB Boost, XGB Boost has been widely used in like a couple competitions. It's a very powerful machine learning tool. And today I'm going to show you how we can do a classification on the Iris dataset. So actually we have two machine learning functions. One is training. The training you probably get it's a batch operation. You get all your data and send to the trainers and create a model, right? Train the model. That's a batch process, right? Batch, because when you train the data, you prepare all your data in a batch, and then you do the inference. And actually, with Timeplus, you can do the inference in the real time. That means every time you get the new data, you run the streaming cycle. The streaming cycle is running there as a long running process, and every time you get a new data input, right? The streaming cycle will process the data, do the inference, and give it output. Now let me show you how to do that in the Timeplus. First, we have this. Let's switch to the code view. We actually already get some of those code. For example, this. Let's take a look at this scikit-learn classification. First, we have this train functions. The train function has the train scikit-learn classifier has 3 input. Let me make it a little bit bigger. Okay, so it has 3 input. The features, which is the array of float, label, specify what type of the classification of these features of this sample. And then here name is actually the model name. We want to save the model locally. So yeah, the process is simple, right? We run the scikit-learn sklearn training. So we get all the features, labels, we convert it to a pandas data frame, and then we call the label encoder, and then we create a logistic regressions and run like a 200 iteration. And then we got this classifier. And then we save the classifier using the name provided in the input functions. And then when the aggregation complete, we just return the model name. Right? That's the trainer. And similar, we have this prediction function. If user give me the features in the array and also the model name I'm going to use, what we are going to do here, we actually load the classifier using the model name, and then we run the prediction, right? And we send the result back to the WeChat string of the classifier. So let's see how it works. Let's go to the Timeplus. This is a data set, Iris data set. So I'm running this I put all the features here in the array, the sepal length, sepal width, petal length, and the petal width. And the varieties is the classify target. We want to classify the variety of the Iris data set. And we gave it the model name called the test sklearn classifier. So let's take a look at, and I will run this aggregation function. It return the logistic regression, because this is just simple data set. It's super fast. We get the result immediately, and then probably I will run some let me run the prediction. I just randomly select one of the samples here. Say I want to predict on this specific data set, right? So let's see what happened here. Okay, it gave a prediction, say, oh, this type of with the feature input, we predict this as a setosal. Okay, so that's how in a real life, you probably don't run this prediction one by one, because with Timeplus, actually we does support streaming prediction, right? So that means if you have input features as a streaming data, and if you run the streaming query, Timeplus can help you to continuously do the prediction and output the result. Okay, so that's how scikit-learn works. Let's go back to the slides and yeah, let's go to the next examples. Is time series forecast, right? Time series forecast is another important machine learning domains that we user has a time series data and they want to do the prediction. There are a lot of libraries like Facebook Profit. There's a stage forecast, developed by Nick Stella, and there's a Darts, the open source time series forecasting framework. And there's a states models, is a Python library based on the statistical models. But most of these libraries are actually under the hood. They're using some statistical models to do the time series forecast, right? Because Timeplus is a streaming data platform. For streaming data, a lot of those streaming data is time related, right? A lot of customers using Timeplus to do the like matrix calculating or time series data processing. So predict time series data will be a very useful tool in the streaming data platform. So in the next example, I will show you how we can leverage state models specific these Python libraries to do a time series forecast. Right. So yeah, for time series forecast, we actually can leverage the aggregation functions here. So let's take a look at this, how this aggregation works. If you have values and timestamp, we actually just appending the data to the time series. And in this case, we convert it to pandas data frame, but we keep the last 12. That means when we do the aggregation, we always keep the back 12 data set and use this 12 data set to do the prediction for the new data. And in this case, we're using the ARIMA model and do the prediction, right? And we predict one next values and we return back to the time tax. Yeah. So let's I'll show you the time series forecast code here, right? Here we call it the forecast aggregations, and it has two input sample, the timestamp and values. Values is float 64, and yeah, for the time series model, we actually don't keep the model. We only keep the time series data because when you have the data, the last 12 data, we can use this last 12 data to do the predictions. So for serialized, deserialized, we just keep that the data set, and we are running single thread prediction, so we don't have to merge. And for the process, like I mentioned, we just uh, get the last 12 data in aggregation using the aggregation, and then we feed the ARIMA model and return one of the data set. Right. Okay, so let's take a look how it works in Timeplus. So in Timeplus, let's say I've already imported. If you take a look at this data set, air passengers. Let's use the table query, which give you all the data at snapshot here. So there's a date. It's a monthly data. So every month there's a number of passengers that it's taking the flight. So what we can do is actually we can visualize this in Timeplus. So let's say to time, we turn the date to time as time, and we want to show the numbers in the line chart. Let's run the query, and we can visualize it in a line chart. So you can see for the time series, so it's like the cycles like every year, it follows the similar patterns every year. And then overall, there's a trend. So the passenger is increasing like in a linear style. But every year, that is seasonality. Every year, the pattern is similar, right? Start with some lower, and in the middle of the year, like in the summertime, there's most passengers every summertime. So but to simulate the streaming, right? Because this is a statistic snapshot of data. There's no new data. We just create a simulator using the random stream uh, to. So I have a view called passenger replay. If you take a look at this, we just create a random stream. We have a random stream here, and we join the real data and using the, because there's like 144 rows, we just use the ID to join. So it's actually repeatedly uh, play the data back and in the loop, right? So if we run this, you can see if we can take sorry. If we run this, we actually randomly pick the one data set from the original data and replay it. And similarly, we can actually visualize this in a line chart, say to date, to time, date as time and number. So if we run this, we got a new streaming data, and we can visualize it in the right. And what I'm going to do is actually I'm going to run this prediction. I'll cancel this query. Going to run this prediction on this streaming data, right? So what I'm going to do is actually, here's the sample. So we just like this one. So we run the latest date as the date and latest numbers. We query from the replay, and we run the forecast on each number on each in-car. And this emit periodic means I want to emit the aggregation result every like half second. That means because aggregation by default, it's the aggregation will only emit every default value is 2 seconds. But in that 2 seconds, actually, I already have a lot of data I want to see. So in this case, we actually can turn a smaller emit periodic here at the 500 milliseconds. So let's run this. You see, as in our code, the first five, if there's less than five data, there's no prediction, right? Because there's no enough time to do the series time series for the forecast. So it only return 0. Only on the fifth data, it start to run the prediction, right? Like this. Okay, so but I want to visualize it to compare what is the prediction with and what is the real-time data. So actually we can do a transformation here. So I can visualize the multi series data. One is the original data, the real data, and one is prediction data. So let me run this. Okay, so with this, we actually just run a redrawing, so we can turn the ground truth data and the forecast data. We reshape, so we can put these data as different labels. If I run this, you see, we actually for this the value 606 is the truth and the forecast is 0. But later on, after 5, we start getting the prediction data and the ground truth data, right? And then we can using this color label and the values. You see, this is the real time. You can see the real time trend, and the yellow one is the forecast, and the red one is actually uh, the real data. And you can see uh, the prediction will gradually match the real data because yeah, it's running the prediction in the real time. Okay, so that's how you can leverage Timeplus to do the real time prediction. Because with the statistical model, it's actually running pretty fast. Uh, you can see we can do the real time prediction without any delays. As soon as the data is coming, we give you the prediction at the same time, and you see how it works. Okay, that's for the. Let's go back to the slides. Okay, next I'm going to show some example of deep learning, right? How we can leverage deep learning tools to build some machine learning applications. So there's a lot of deep learning tools, but most popular one, PyTorch and TensorFlow, right? So one by Meta and one by Google, right? I think now the PyTorch even more popular, even though TensorFlow was the first deep learning framework, but now PyTorch is more widely used. The other one you mentioned is the Hugging Face. It's not a deep learning framework, but it's a very popular platform for natural language processing. And a lot of the big data models, APIs, and data set are hosted on the Hugging Face. And at the same time, the Hugging Face has a very easy to use tools called transformers. You can just load the model and run the transformers. I will show you how we can leverage these tools to build some Python UDF and run some real-time machine learning. So first one is classification. I can show you some examples on how we can use PyTorch. You can use PyTorch to write a neutral language, neural deep learning neural network to do the classifications. So let me show the examples here. So here's the code. So you can similar. You have a trainer, you have a prediction, and the trainer you put the features similar as the secular one, right? You have features, labels, names, but you create your own PyTorch based neural network, and you can train the network, right? Train and then print the result, right? It's and for the prediction, it's similar. You just load the model, run the neural network prediction, and return the result. So I'm not going to show this case because I will share the code example because it's all these code are in a public repo, so you can learn and if you want to use it, right? Because the result is same as the secular one, so the input and output is similar. Just the training process is different because for the secular one I show you a regression model, right? Logistic regression model to do the classification. Logic, but for the for secular one we use let me double check. Yeah, we use this logistic regression model to do the classification. Uh, but for the PyTorch we build our own neural network, right? That's different. Okay. But which one to use, right? Sometimes, do you want to use neural network to do the classification, or you want to use the secular one? Or even like mentioned, there are a lot of other tools, right? Which to use? For the neural network, there's some pros. If you want to use neural network, so it's better for the complex patterns. If your data is complex, right, and you want to learn those hierarchical features or non-linear features, non-linear patterns, uh, neural networks is great, right? You in that case, and it can handle large, high-dimensional data. If your data has a lot of dimension, neural network is good handles data. For example, the images and like text, time series data. Usually these data are high dimensional data. Also, you don't need to do the feature engineer. If you run the machine learning like traditional machine learning, you probably spend some time to create your features or decide which feature to use. But with neural network, actually you don't have to do this because the network will learn those features automatically for you. But at the same time, there's some limitations for the new if you want to use neural network to do the classification of the traditional machine learning stuff. First, usually you need more data, right? If you don't have enough data, it's hard to train a neural network. And the training time is usually you spend a lot of time to do the training. Also, it's hard to tune. There's a lot of parameters like number of layers, activity functions, learning rate, something. Uh, it's hard to tune, and it's hard to interpret it because the neural network has a lot of parameters. Let's make it a black box. You don't know how it works, so it's hard to interpret it. The last one is prone to overfit. Overfit means actually because the neural network has a lot of parameters, it probably can remember your test your training data set. It remember everything, so it's very prone to overfit. Well, there's some other cases. That's for the in other case you don't have to build your own neural network, but one of the other case is you can leverage Hugging Face transformers to do the embedding, right? So here's the embedding UDF. Embedding is like uh, you turn a data into a numeric representation. The data is just a vector of numbers. So, for example, if you have image, you have text, you have voice, and you can turn this data into an embedding. So with Python UDF, we can actually leverage the transformer library provided by Hugging Face to do embedding. Here's the code. It's quite straightforward, right? If you have some models, you can do the train the tokenizer. You can create a tokenizer. You can train the you can have this embedding model to give you the embedding. So let's take a look how this embedding works. So you see the time series is still working, right? It's let me cancel this prediction here. So I'm going to show you the embedding one. So we already have this embedding. I think we have this embedding UDF. Do we have that? Yeah, transformer embedding. I already create this function. You actually can show. We can use this transformer embeddings. If you click here, you can see which model to use and what is the input. Let's say I have input hello world, and the embedding I'm going to use is I think we in this sample we support some different models called bird. Maybe I just use one of this. Let's use bird based on case as our model to use, and we can run this transformer embedding. So under the hood, the Python UDF will call this transformer functions and turn this hello world into a vector. Right? You see, this is the vector format of the hello world, right? Yeah, I can talk about how with Timeplus we actually can store this vector as you can use Timeplus as a vector database, and with this embedding, you actually can build your vector search, right? The distance-based vector search. So today I'm not going to talk about that, but if you're interested in that part, let me know. Okay, let's go back to the slides. So okay, here. So and the last one is actually sentimental analysis. Similarly, if you have a hacking phase, you actually can load this, there's some sentimental analysis pipeline. That means if you give, you have an input, it give you some scores. Let's run this as well, right? It's a straightforward. You just create this sentimental analysis. UDF is a scalar UDF. For each input, it give you a score on the input functions. So let's take a look at these functions. They called let's see. Yeah, I think it's called sentimental transformer sentimental analyzer. Analyzer is my function name. So I'm going to run this. Select. And if you have an input, we can check whether it's from the sentimental analysis give you a positive score or negative score. So say just say hi, nice to meet you. And how about that? So you see the output is a label. It's it's positive, and the score is like a 99%, right? 99. So that means hey, this is a very positive word. So it's with this you actually if you are doing some analysis in the real time, right? You have a lot. If you are connecting to your uh, whatever the social network stream or some other data stream that is language, right? It's a language based stream, and you can do the analysis in the real time whether they're speaking about in positive way or in a negative way. Okay. Okay. That's for the deep learning one. And I'm going to talk about the AI and the LLM. So today, the software has been changed by the large language model. So there are a lot of large language models like OpenAI, Gemini, Cloudy. These are all good ones. And if you want to run some open source model locally, you can run Llama, or there's a cloud one as well, Grok. You can using Grok to run those open source model, providing on on the cloud. Or if there's a DeepSeek, it's also a open source model, but it's super high performance and low cost, right? And with Python UDF, it's actually very easy for the user to integrate with your AI. So next, I'm going to show this the function called the char function, and we will directly call the the chart GPT 3.5 model and doing something, right? So the code is quite simple. You can see here it's a Scala function, input a string, return a string, and we just send them all the data to OpenAI, and then we see what's happening, right? So let's directly go to this example here. Let me close it. So first, I think we already have this. We already created this chart functions. So let me. So if you want to run this SQL, say uh, hi to the. We actually, if you run this, we actually send the data to the OpenAI. You can see hi, what I can assist you today. So what you can do actually with this SQL, you can actually can create some real-time data processing, and you can send some real-time data to the large language model and return back. For example, I want to know I have an application that turn the city name to the airport name, airport code. Right? I don't know what airport is. I don't have the lookup table. Yeah. What I can do is actually, AI. There's already because large language model has already been trained by those knowledge. So you don't have to create another lookup. You can actually leverage the large language model to do the lookup for you. So here, so what is the airport code, for example, for Vancouver, which is where I live. Vancouver. See, you can see if we send this simple query to AI, it knows the airport code for Vancouver is actually YVR, right? So how can you build this data transformation or data lookup application easily? Actually, it's quite simple. Say we just say because this part is the code, right? So what I can do is I can call concat code, which concat the let's see concat the questions and the city name and yeah probably the I put this question here as well. So chart here, and for example, if you have a let's see, I put Vancouver here as the input data. You can see that here I'm just showing in a task SQL, but in reality, you can see this from is from a real-time data stream. So Vancouver as city. Okay, so if you run this, I believe it should be the right way, right? If you run this, you actually just create send the city name to the city name stream to the RM in the real time. What else we can do is we actually can, because this the airport code for Vancouver is YVR. We still need the data to processing this, right? So usually we can say, hey, large language model, please put the result in a JSON format. Let's say return the result in a JSON object. So this will turn the result in a JSON. So the airport code is YVR. So by doing so, we also can say set the key as code. So we don't want to use airport code, we just say the key is code. You see, we got this air code YVR. So later on, we can handle this in a real-time stream easily, right? That's how you build a data application, and you can send your data to RM in real time using the Timeplus streaming SQL and Python UDF. That's super straightforward. So, and it's also very powerful. Okay, let's go back to the slides. I think that's all I want to share today. So let's do some summary. So first, there's some takeaways. Timeplus is a high performance streaming processing platform where SQL is the main interface. Um, while leverage Python UDF, Timeplus can actually provide as an integrated data processing tools for data science, data engineer, and software developer, because you don't have to choose whether I have to use SQL or I have to use Python, because with this Python UDF, Timeplus can unify these tools together. You can use it's the same interface as SQL, but under the hood, you actually can call Python as well. So, and leverage Python UDF, it is easy to support different application or scenarios like machine learning and AI scenarios, like traditional machine learning, where I demonstrate how we can leverage scikit-learn to do a batch training and run a real-time prediction. And you can use those statistical model to do the time series forecast. In the example, I show you how we can leverage state forecast to do the real-time forecast, right? And you can also leverage those deep learning tools to do the natural language processing. We show you how you can do the embeddings and how you can do the sentimental analysis using the Hugging Face transformer libraries. And last week, we show you how you can actually send data to large language model to do the real-time processing, even because it's Python, right? Even you can leverage those agentic workflow to do some even more complex processing. Okay. Thank you, everybody. If you want to know more about this, if you think what I'm sharing today is helpful, you want to know more about Timeplus, please go to timeplus.com. There's some I think all the information about Timeplus is there. Also, I think today's code I'm showing here. There's a in the example Timeplus IO. There's a example photo, example repo, and there's a Python UDF. All the example I shared today are there. All the you can if you want to try, you can download our Timeplus Enterprise or our Docker images to try this